All right, we're back with Unit 11, Day 3. This is going to be a review of yesterday of Day 2, double distributing, but there's going to be a couple like little special cases. So these are the steps again. If we were to double distribute, we're going to multiply the first term and the first binomial by the first term and the second binomial. My next step is multiplying the first term by the second term now. And then my next step would be to multiply the second term by the first term. And then last, we're going to multiply the second term by the second term. And that will multiply all four things. So the first example says x minus 5 squared. Whenever I see something squared around a binomial, which means two terms, I have to write it 2 times. If I just try to square everything that's inside, it actually won't give me the correct answer because I get x squared plus 25, and that's actually not the correct answer. So once you write it twice, now we're going to double distribute. So we would take this x and multiply it by that x. So that'd be the first term times first term. So it'd be x squared. First term times second would be negative 5x. Second term by first term is negative 5x. Second term by second term is plus 25. We look to see if there's any like terms that we can add together. And it's these two. So now if we add those together, we get x squared minus 10x plus 25 is my final answer. That's a quadratic trinomial, if you're going to name it. Example 2 is very similar. It's x plus 3 squared. So whenever I see that squared, I have to write it twice. Once I write it twice, I can do my double distribute. So we have the first term times the first term by the second by the first, and second term by the second term would give me 9. If I combine like terms, those 3 x's in the middle can combine, and I get x squared plus 6x plus 9. And that would be my final answer. That's also a quadratic trinomial. This next one's a little bit tougher because it's a binomial times a trinomial. So that means 2 terms by 3. We still follow the same basic steps where the first term is multiplied by all 3 terms now. And then the second term is multiplied by all 3 terms. So in the end, we should have 6 multiplications if you do this correctly. Because it's a binomial times a trinomial, that means 2 by 3. Well, that tells you 2 times 3 should give you the 6 that I'm talking about. So now if we did this correctly, 3x times 2x squared would give me 6. And then x times x squared is x to the third. 3x times 5x is 15x to the second power because x times x is x squared. Then 3x times 3 is 9x. The second term by all 3 would give me negative 2x squared, and then negative 5x, and minus 3. So now if we combine like terms, we get 6x cubed plus 13x squared plus 4x minus 3 in the end. And if you're wondering what we'd call that by name, that'd be a cubic polynomial. If we name that. All right, let's go on to the next page. Pause it if you need more time. So these are similar to yesterday. What I'm going to do here is do all the odds with you, okay? So the first odd that we're going to do is number 1. So we take the first term and multiply it by the first term by the second by the first, and the second by the second. So it gives all 4 multiplications. So the first times first is 25, and then we have an x squared. And then the next would be the first times the second would be negative 15x. And then the innermost ones next to each other, so second times first would be 5x. And then the second term by second term would give us minus 3. So if we combine like terms, we get 25x squared minus 10x minus 3. And that'd be a quadratic trinomial again. So that'd be number 1. Number 3 is one of our special cases with this, because if we multiply this correctly, we do the first times the first times the second by first, and the second by second. You're going to notice something that happens to the middle terms, because these two binomials are known as what's called conjugates, and they're the exact same binomial but opposite signs in between. So that's going to do something to our problem. So if we multiply those together, that'd be x squared for the x times the x. The first term times the second term would be negative 10x. The second term by the first term would be plus 10x. And then the second term by the second term would give us minus 100, because that'd be 10 times negative 10. If we notice these two middle terms now, they actually are exact opposites of each other. So this would be a time when those middle terms would cancel each other out. I'm left with x squared minus 100. And that'd be my answer for number 3. Number 5. If I see something squared, this is where I'm going to write it twice. When we multiply these, the first term would give me a 4x squared. The first term by the second would give me negative 6x. The second by the first would give me negative 6x. And the second by the second is negative 3 times negative 3, and that's plus 9. The middle terms there, when you add them together, will give us negative 12x. So this would be my final answer if you multiply those two binomials. So whenever you see something squared, you got to write it twice and then multiply. Same thing with 7. We see something squared here, so we got to write it 2 times. So we're going to write 4x minus 6 and 4x minus 6. So if we multiply this out twice, 4x times 4x is 16x squared. 4x times negative 6 is negative 24x. Negative 6 times 4 is negative 24x. And then negative 6 times negative 6 is plus 36. If I combine like terms, we get 16x squared minus 48x plus 36. And that would be my answer if I added those together. And then 9. 9, if we do my multiplication, it would be m squared times m, which is m to the third. M squared times 12 is 12m squared. The second by the first term would give me plus 4m. And then the second by the second would give me plus 48. I don't think that I see anything that can combine, because there's nothing with the same exponent. So this must be my answer. If I needed to name this, this would be a cubic polynomial. And that covers all of the notes for day 3. So I'll see you tomorrow. Have a great day.